All right, today we're talking about graphing linear functions. So we're going to talk about two methods. All right, the first method is called plotting intercepts. So question is, well, not the question, but the key word here is intercepts. What do they mean? They mean two different intercepts. One is the x-intercept and the y-intercept. Okay, so what do we know about those two things? Well, let's take a look. So I need a graph paper. There's my graph paper. Move that up here. A little bit more. Okay, let me shrink this down a little. Okay. All right, so let's take a look at this. So we said that the x-intercept, is where it crosses the x-axis. Okay, so no matter what point here that I plot along the x-axis, these are all x-intercepts, right? Every single one of these are all x-intercepts, okay? And what do you notice if you plot all these points? What you would notice is that, okay, let's start from left to right here. This would be negative 9, 0. Negative 8, 0, negative 7, 0, negative 6, 0, negative 5, 0, negative 4, 0. What stays the same? The 0 stays the same, right? What value is it? Well, it's a y value. So with x-intercepts, what we know is that y is always going to equal to 0. Well, similarly, with the y-intercept, same thing. If I can plot all these points here, which is where it crosses the x-axis, and each of those points is going to be 0, 1, 0, 2, 0, 3, 0, 4. So what stayed the same? The 0 did, right? And so the x is always equal to 0. Okay, so let me just plot a point here and put an arrow on this. Notice how this point is 0, negative 5, right? While, let's say this right here, I'll plot this point right there and put an arrow on that. And we notice that this is 5, 0, right? So notice the y value is equal to 0 on x-intercepts. With the y-intercept, the x is equal to 0. So when we want to plot using intercepts, that's what we would do. We would just set the x equal to 0 and the y equal to 0 and find my 2 points that way. And you're like, well, what do you mean find your 2 points that way? So here we go. Let's try this. So let's say we're given x plus 4y equals negative 4. Okay, and it wants me to plot this using intercepts. Okay, so plot using intercepts. Okay, so what I would do is say, okay, great. I'm going to use the intercepts. So I'm going to find, so my first step is to find my x-intercept. And this is the way I would write x-intercept in short. What I know about x-intercept, that the y is equal to 0. Great. So then I'm going to solve this. Okay, so I got x plus 4 times 0 is equal to negative 4 So I got x plus 0 is equal to negative 4. So x is equal to negative 4. So in this case, I have a point, right? My point is negative 4, comma, 0. And then next, I want to find the y-intercept. What I know is x is equal to 0. Okay, great. So I got 0 plus 4y is equal to negative 4. Okay, 4y is equal to negative 4. So y is equal to negative 1. So same thing. This would give me a point of 0, comma, negative 1. And the way I got the negative 1 here is I divided both sides by 4. Okay? Negative 4 divided by positive 4 is negative 1. Okie dokie, in case we were wondering. So now I got 2 points, right? So great. So I go back to insert, file, graph paper, awesome. I need it up here somewhere. I need it shrunk down a lot. And let's get this closer to here. Boom, right there. Awesome. All right, so then I'm going to plot negative 4, 0. And I'm going to plot 0, negative 1. And there shall be my line. If I can get it right. Let's just do it this way. Probably easiest. And there you go. And therefore, there is my line using the intercepts. So be careful. In my last plus, when they ask you to use the intercepts, they expect that these 2 points are on the intercepts, on the x-axis and the y-axis. Okay, so that is one method of doing it, is applying intercepts. What's the second method? Well, second method is called is basically getting y by itself so that you have y equals mx plus b. Okay, so if you get y by itself, you get y equals mx plus b. So what is y equals mx plus b? So y is equal to mx plus b. Oh, by the way, I don't like using intercepts, and the only reason why I don't like using intercepts is only because it doesn't always work. Okay, it doesn't always work. There are situations that it will work, and there are situations where you're going to get fractions for these numbers here, the x and the y here, which is very hard to graph. Okay, so just be careful. You can't just depend on plotting with intercepts. Now you can depend on this, okay? If you want, you can certainly depend on this. This will work every single time. And what was this called? This is actually called the slope intercept form. Okay, why is it called a slope intercept form? Like I said to you before, we are so good at coming with names. So why is it called slope intercept form? So let me change some of these colors here. Let's change that to red, and then let's change this here to green. Okay, so so it's called slope intercept form because the b is my y-intercept. And y-intercept is actually a corner point, 0, comma, your b value, okay? And the m is my slope, or as they would call it, rise over run. Okay, so rise over run, what do I mean? So rise is up and down. So if I go up is positive, if I go down is negative. And run is to the left and right. If I go right, it'd be positive. If I go left, it'd be negative. Okay, so let's do an example of that. Actually, let's do the, do we want to do the same problem? We can do that. Let's do the same problem. All right, so x plus 4y equals negative 4. Okay, so again, given x plus 4y equals negative 4. Okay, so I want to get y by itself. So in order to do the slope-intercept form, you do have to be pretty good at getting y by itself. Okay, so again, y is just a number, x is just a number. Okay, they are dependent on each other, and hence the relation. But just pretend that it's it's a number that you're trying to get alone. All right, so first thing I got to do is subtract the y. So again, I want to solve for y. So that means I got to get rid of this and this. All right, so I'm going to subtract the x over, so I'm going to have a big blue blob. 4y equal to negative x minus 4. Okay, so notice that the x, when I roll it over, I subtract x to both sides. These two are not like terms because they are not like terms. Okay, you can't add them two together. Then I have to divide by 4. So instead of dividing each side by 4, which is what you typically do, dividing the 4 on the right side is the same as dividing each thing by 4. So if this is the case, then I got y is equal to negative 1/4 x minus 1. Okay, so remember that there is an imaginary 1 here in front of that x. So there is an imaginary 1 right there. Okay, so that's why it's a negative 1/4 x minus 1, because negative 4 divided by 4 is negative 1. Okay, so now I got this equation here. So again, okay, so again, I want to tell you that the slope is negative 1/4, which means that I'm going to go down 1 and go right 4, because the 4 is positive, so I go right. The 1 is negative, so I go down 1. And this is my y-intercept, which is 0, negative 1. Okay? All right, so how do I graph this? So let's insert a file. Hello. Put a graph paper over here. All right. Okie dokie. Get a little bit bigger. All right. So the way you would start with your plot is that you would start with so in other words, you don't know how to move unless you know where you are. So it's kind of like let's say that you're wandering around and all of a sudden you're lost. So you call a friend saying, hey, can you give me some directions back home or back to your place? And the first question they're going to ask you is, where are you? Right? And if you don't know where you are, they're going to be like, well, how am I going to get you here? Right? So you need to know where you are before you can move with the slope. So if you think the M that stands for slope is move, then in order for you to move, you need to know where you are. Okay? So the first thing I got to do is plot the y-intercept. Y-intercept is 0, negative 1. So I plot that. And the slope tells me to go down 1, right 4. So Look at, watch this. I'm going to go down 1 and right 4. 1, 2, 3, 4. Okay? So now I have a line. And that's how I would draw my line. Look at that. Does it look pretty much the same as that? Yes. But notice that the 2 points that are plotted though. Notice the 2 points that are plotted. It is definitely not the same 2 points if I was to use the slope-intercept form, okay? But the graph, exactly the same, okay? Now, MyLast+ will mark, if they're asking to use intercepts, they will mark this one correct, and they'll mark this one wrong, okay? And these two are the same exact graphs, all right? Why? Because your 2 points plotted here are both intercepts, and the 2 points plotted here, one is the intercept, one is not, okay? I hope that helps as well. All right, what else is there? Okay, so far, well, I'll keep on going. So let's talk about vertical and horizontal lines, because if we have a line, it can only be diagonal, horizontal, or vertical. Those are only 3 possibilities that we have. So how do I graph if it was just a horizontal or vertical line? Okay, so let me insert in here a vertical line as well as a horizontal line, okay? So I need to shrink these a little bit. So let's shrink this, move this over here, and no. Okay. So I hope you can see these 2 lines here. I will make it look a little better here. Okay, so let's see. The green line I can reproduce here. So the green line looks something like this. Boom, right there. And then let's make a purple line. Oh, let's just use that. Oh, there's my purple. Okay. And let's make a purple line. Okay, so there's my 2 lines right there. All right. One's horizontal. So this one right here is horizontal. And let me just add another pen, and let's call it green. There we go. And this here is vertical. Okay, so actually let's bring this over here. Okay, so there's vertical. All right, so one's horizontal, one's vertical. How do I know what the equation of these 2 lines are? Now the vertical you kind of already experienced a little bit, but you didn't realize that you experienced it. Okay, so looking at this, if I was to, let's say, plot some points over here, okay? So let's plot a point here and a point here, okay? And here's the funny part is that I show this every semester, but the problem is that people are, sometimes don't really want to put in the work to make it happen, so therefore they kind of lose out, okay? So if you guys notice that one of these blocks is 1, okay? In this case, -1, because it's going down by 1, okay? So it's -2, -3, -4, and -5, all right? So, all right. So if I was to look at this point right here on the left, that is going to be a -2, -3, okay? And this one on the right is going to be 1, -3, okay? So in other words, if I'm given a horizontal line, I plot 2 points. When I plot 2 points, what does it show me? It shows me that there's two numbers that are exactly the same. -3. Excellent. Well, which value is that? It's the y value. Well, guess what, guys? You now know the equation of that line. It's y equals -3. Pretty simple, right? Now, same thing. Now, you got to be able to go both ways here. You got to be able to take the equation, take a line and write the equation of it. And you got to be able to also be given an equation and be able to draw that line. I would do exactly the same thing. So if I was to go backwards, this equation right here says that the y is always going to be -3. Okay, so I draw 2 points, -3, -3, right? The y is always going to equal -3. So if I plot a third point, the y is still equal to -3. Or I plot the fourth point, the y is equal to -3, right? Now I can just put in some numbers and plot those, two of those points, and you're going to see when you connect the dots, you're going to get a horizontal line. Okay? Oops. So this is the equation of that line. Okay, how about the vertical line? Well, vertical line, I want to do the same thing. Okay? I'm going to plot a point there, plot a point there, and find out what the coordinates are. Okay? So this one here on top is 2, 1, and the one on the bottom is 2, -1. Well, what stayed the same? The 2 did. What value is that? The x value. Well, guess what? You just also found the equation of a vertical line. Okay? So notice the difference here, guys. Notice that I just plot 2 points and I find out. Now, a lot of times what you guys try to do is go, okay, x equals, x equals, x equals. Is that a vertical line or horizontal line? Well, maybe it's a vertical line. Maybe it's a horizontal line because it's x. And maybe the y is a vertical line because it's a y. Well, stop thinking that way, guys, all right? Just plot 2 points and be sure of it, all right? Be sure of it. Know that your answer is right, all right? So that is how you would find that. Now, so let's summarize really quick. Notice here, my slope is negative. Notice what the graph did. It went downward. Okay, it went downward, not just downward, well, I was saying, downward from left to right. Okay, so it's kind of like skiing, right? It's kind of like skiing where if this slope was steeper, it'd be a faster hill, right? You'd be, Where now, if I apply it here, this is kind of like a nice little slope. It's pretty fair. It might be the bunny hill. Heck, and then if it was closer to this, it'd be even slower. Okay? So I want you to think about that. All right? So let's summarize here. So number 1, so far I have 1, 2, 3 types of equations, okay? So I'm going to write here what variables are in my equation. Okay? Where am I in my equation? All right. So all right. So if in my equation I have an x and a y in it, so in other words, y equals mx plus b, I know that I have a diagonal line, right? And I know that if I go from left to right and it goes downward, oof, that's awful. That's why they give you these tools. If it goes from left to right going downward, then I know that this is a negative slope. However, if the diagonal line is going up, going from left to right, I know that this is going to be a positive slope. Okay? All right, so what's in my equation? What variables are in my equation? So if I have x only, meaning no y, all right, which is this green one right here, that means I have a vertical line. And what about the last one? The last one says it's going to be y only, no x, then that's going to be a horizontal line. Okay, so those are some of the things you need to think about, all right? We will talk about their slopes in the next section, all right, of what the slope of a vertical and horizontal lines are, but we will get to that. I just want to make sure that you're covered with everything on the homework. So there is one, so they're going to give you word problems. So let's see here. Word problem is this one right here. So let's move this over to where it needs to move over to. All right. All right, so if you look at this problem here, it says the production supervisor at a particular office products company finds that it takes 4 hours to manufacture a table for one of its special dining room sets. Each chair takes 9 hours. So chair takes 9 hours, okay, to manufacture. A total of 9,000 hours is available to produce tables and chairs. The linear equation that models this situation is y equals 4x not plus 9y equals 9,000, where x represents the number of tables. Okay, actually, you know what? Let's do this better. Let's use this. So what I'm going to do is this. X represents the number of tables. So let's do, so X for tables. All right, and table takes 4 hours. Okay, and then I want to use green for chairs. So chair takes 9 hours. And y is the number of chairs produced. Okay, so I have this equation right here to look at. All right, so there we go. This is where we start. So again, I'm going to write down here that x is equal to the number of tables, and y is the number of chairs. All right. Then I'm going to go into it. So part A here is asking you to complete the ordered pair solution where the x value is 0 of this equation. And it says describe the manufacturing situation that corresponds to this solution of the ordered pair. So the x value is 0. Well, what does the x represent? X represents the number of tables, right? So in other words, if there was no tables, how many chairs can you produce? Okay, so again, I'm going to point this out that the x value is 0. All right, so then I'm going to come down here. I'm going to say, okay, part A. What I know is that x is going to equal to 0. So I go that route. So 4 times 0 plus 9y is equal to 9,000. So 9y is equal to 9,000. So y is equal to 1,000. Okay. So in other words, I have a point here. 0, 1,000. What does that stand for? Well, x is tables. And y is chairs. So in other words, if I was to focus this 9,000 hours to do no tables and only focus on chairs, I can make 1,000 chairs. Okay? This is describing a manufacturing situation. Again, we said chairs are y, so how many chairs? 1,000. How many tables? 0. Right? And now it shows you that it wants the y value to be 0. Okay? So part B, y is equal to 0. So I go, okay, 4x plus 9 times 0 is equal to 9,000. 4x is equal to 9,000. So what's x equal to? So let's take 9,000, divide by 4, and I get 2250. Okay? So now, again, I have a point of 2250, comma, 0. So again, my y value is 0, my x value is 2250. So what's my x value again? My x value is tables. So this would be my tables. And this would be my chairs. Okay? So that means I can, if I made no chairs, I can make 2,250 tables. So this asks, hey, so I said 2250. And now it says describe the situation. So again, chairs are y. So my chairs is 0. 0. And how many tables? 2250. So if 30 tables are produced, find the greatest number of chairs. Okay, so 30 tables. So tables was highlighted in blue. So this is telling me if 30 tables. Okay, so tables is my x value. Okay, so part C, x is equal to 30, right? Because it says, again, 30 tables. Table stands for x, so that's why x is equal to 30. So, okay, so I have 4 times 30 plus 9y is equal to 9,000 hours. I got 120 plus 9y equals 9,000. Okay. Let me see, 4 times 120. So I get 9y is equal to 8,880. So y is equal to 986.6 repeating. So the question is this, is that would the answer be 987? Because it was 987, do I have enough time to finish that chair? And the answer is no, I wouldn't have enough time. Okay? So that means I can only make, so when x, yeah, I can do that. When x is equal to 30, I can only make 986 chairs. I can't finish, because if I was to finish that chair, I would go past my 9,000 hours. Okay, so that is all I can do. So how many chairs? 986. Okay, I hope this helps. If there's any questions,